Welcome back, y'all. Talking more some Algebra 3 here. We're finishing part 2 now, R7 here. So we're talking about adding, subtracting, and multiplying and rationalization. Wow. So let's kind of start with some basics real quick. So when we look something like this, 7 plus 4 plus 7, what do we get? Yeah, we get 11. What about 4x plus 7x? What do we get there? Yeah, 11x. What about 4x squared plus 7x? You can't add those, so it just stays as it is. Again, when we're looking at this, these get treated similar to the numbers. If the numbers are both constant, they're both numbers, you can add that. But if they're not the same, you can't add this. Like here, we had the same variable. Here, these are two different types of variables. So let's look at this then. That being said, we got 4 radical x plus 7 radical x. Are these the same? And by this, is the whole radical and the radicand inside the same? They are. So when you add them, you get 11 radical x. But what about this one? You got 4 radical x plus 7 cube root of x. Can you add those? Can't add those right there. So we're just stuck with 4 radical x plus 7 cube root of x. So that's part of adding, subtracting. These have to match. Similar to any of these up here that we've done before, these also have to match very similarly. So let's look at this right here. So here I got 5 radical 2 plus 3 radical 32. Do these match? No, they don't. But can we simplify this? Yes. So 32 is a number that can be simplified. What perfect square goes in 32? 16. So that's where we're going to split it up. We're going to split 32 up into radical 16 times radical 2. Now we still have that 3 in front from the very beginning. Everything drops down. 5 radical 2 plus 3 times 16 times square root of 16 times radical 2. Now, the radical 16 does factor out. It does become a whole number 4. Square root of 16 is 4. This stays as radical 2. Now, this whole time, this has been multiplying with itself. So even when we split the radical 32 up to radical 16 radical 2, they're still multiplying. So it's 3 times radical 16 times radical 2. Square root of 16, you get 4. So then you can actually then multiply these two numbers. You get 12 radical 2. And that radical 5 comes down all the way down. So sorry, 2 radical, or 5 radical 2. Now we got 5 radical 2 plus 12 radical 2. What does that give us now? Yeah, that does add up to be 17 radical 2. So then go ahead and kind of pause this and then try these yourself. Now, on this one, you should have split that up into radical 4 times radical 5. And then the 6 comes down. This stays. This one will factor out to be 4. And then radical 9 times radical 5. And then this last one, see what would that be? So if 5 goes into that, 1 times the remainder of 3 will be radical 16, radical 5. So this factors out to be 6 times 2 times radical 5. Here we get 4 times 3 times radical 5. And then we get 4 radical 5. Let's simplify that right there. 6 times 2, we get 12 radical 5. Minus 12 radical 5 plus 4 radical 5. So we got 12 radical 5 minus 12 radical 5. That gives us 0. And then plus 4 radical 5. Our final answer is 4 radical 5 right there. All right, let's look at this one right here. Same idea. Now, here, you can factor out the x. So you got radical 2 times radical x squared. And we talked about those right there. And we'll keep going here a bit. Here we get 6, and then we get, I think this was supposed to have a radical 2 right there. Yeah, it was. No, it doesn't. Let's leave it off. And then we get radical 4, and then we get radical 5x. Now we leave the x with this because you can't split that up. You know, here we can do something with it. Here we can't. And then you get 5, and then you get radical 4, radical 2, and then radical x squared. There we go, because 4 times 2 times x squared is 8x squared. So as we simplify this, we get 8, and then the x squared becomes just x. That's the only thing that factors out, and you're just left with the radical 2 right there. Here, the 4 factors out. The 4 does factor, so it'll be 6 times 2. Oh, the square root does have a root. You're left with radical 5x. And then here, the 4 and the x simplify. You get 5 times 2 times x, and then you're left with the radical 2. So understand that came from there, and that came from there. So here, when we simplify this even more, we get 8x radical 2 minus 12 radical 5x, and then minus 10x radical 2. We look at this whole thing, we see what is similar or the same. These two right here are the same. This is not, so that's okay. So we got 8x minus 10x. That gives us negative 2x radical 2. And because we couldn't do anything with this is just attached at the very end. Minus 12 radical 5x. And that's okay. This is still simplified as much as it can. We went from these 3 terms to these just 2 simple ones right there. So that's adding and subtracting right there. So let's look at this. How about multiplying? So when it comes to multiplication, you can only multiply things under a radical with other things under a radical. So for example here, radical 3 times radical 2 gives us a radical 6. And that's okay. We're done right there. But here, let's look at this one. Again, same thing. You can only multiply things that are under the radical with under the radical, and things outside the radical, they multiply with each other. So we get 2 times 4, we get 8, and then 5 times 6, we get radical 30. And it stays like that. That is simplified right there. But what about something a little bit more complex like this? Understand, this is still 2 terms. 1, 2, 1, 2. This is no different if you had an x minus y times an x plus y. We gotten so used to doing something like this that we don't recognize that sometimes when we use actual numbers. But it still works the same way. We still distribute. So we take this times that, and this times this. And the second terms times the first terms, and the second term times the second term right there. So radical 8 times radical 8, that gives us radical 64. Radical 8 times a negative 2 radical 5. Remember, the outside number stays with the outside number, so it's just 2, but then it's 8 times 5. Get radical 40. Let me make some room right here. Then we're going to go ahead and multiply the second term. We'll get 2 radical 5 times the 8. You get negative 2 radical 40. Oh, it's positive. Right there, positive. And then 2 radical 5 times 2 radical 5. So here's where it gets tricky. So we get 2 times 2. We get 4. And then radical 5 times radical 5 is a radical 25. Right there. So then let's go and simplify this. So here we got a negative 2 radical 40 and a positive. They cancel each other out. Hallelujah. Because that was complicated. Now we got radical 64. That becomes a whole number 8. Minus, you got 4 radical 25. Well, 25 does have a square root. That is 5. So this becomes minus 4 times 5. So we have to simplify that first. We get 8 minus 20. So our final answer would be negative 12 right here. Perfectly acceptable. Now, here we got radical 2 minus 5 squared. Now, just like any other binomial, that means you have 2 of these. So this becomes radical 2 minus 5 times radical 2 minus 5. So same thing, we distribute here. So radical 2 times radical 2, radical 4, radical 2 times a negative 5, negative 5 radical 2. Same thing right here. You're going to get negative 5 radical 2, and then negative 5 times negative 5, positive 25. Let's simplify this. Square root of 4 is 2. We get 2, and then because these are similar radicals and radicands, we end up adding these two. We get negative 10 radical 2, then 25 at the end. It was it, yeah, 25 plus 25. Add like terms, we end up getting 27 minus 10 radical 2. All right. So rationalizing denominators or numerators. So in the whole idea of radicals and simplifying all this, ultimately you can't have a radical in the denominator. When we want a final answer, a proper final answer, we do not want a radical in the denominator. Now sometimes they'll ask you, hey, get rid of the radical in the numerator and then figure things out. Crazy, I know, but we're going to focus on the denominator side of things right here. So when you have a big old radical over one huge fraction, you can split that radical up into a numerator radical, so the cube root of 2z yz, and then the cube root of 250 z4. But check this out. Before we do this, rules of fractions still apply here. You can still reduce before we do that. So let's do that. Let's reduce the z with one of these, giving us a cube z. And then that will make a little more sense right there. So now that we have that, we're able to split it off. And then you can reduce the 250. We're left with just a y in the numerator. In the denominator, we're left with what? We're left with cube root of 125 z cubed. Now, there is no cube root of just y, so that just stays as cube root of y. But this does have a cube root. 125 will break down to be 5 times 5 times 5, or 5 cubed. So you're left with 5 cubed z cubed. Well, the cube root of 5 cubed is just a whole number 5. The cube root of z cubed is just z. The radical in the denominator is gone. Same thing right here. We split it up. Left with radical 3 over radical 2. So, again, we cannot have this radical in the denominator. So, as we talk about right here, a conjugate, as in math, is an expression that you multiply to get rid of the radical. Well, sometimes, in this case, when it's just a single term, you multiply with the exact same radical in this case, because a radical 2 times a radical 2 gives a radical 4, which then simplifies. Exactly. As we look in the next one here in a bit, sometimes also it's a difference of squares counterpart, as we'll see. So right here, but when you do to the bottom, you have to do to the top. We have to multiply the top with a radical 2 as well, because technically radical 2 over radical 2 is just 1. So we're not changing the value, we're just changing how it looks. So radical 3 and radical 2 gives us radical 6, radical 2 and radical 2, radical 4, which is square root of 4, y'all. Yeah, it is a whole number 2. As long as your radical and the denominators are gone, then you have rationalized this perfectly. So let's look at this with counterparts like this now. Should be a fraction. There you go. So the conjugate here is very similar to what we did right here. Let's look back 2 ago. So these two right here are conjugates to each other. They're multiplicative inverse of each other. Because when you multiply them, ultimately your final answer will get rid of the radical, as we did right here. This is an example of that. So a multiplicative inverse of this, the conjugate of this, is the same thing, a radical 3, but instead of a minus 1, it's a plus 1. And again, what you do to the bottom, you have to do to the top as well, plus 1. So here, you still distribute radical 3 and radical 3. We get radical 9. Radical 3 and 1 is positive radical 3, but then you do negative 1 times radical 3, you get negative radical 3. And of course, the negative 1 times the positive 1 is a negative 1. These cancel each other out. Square root of 9 is 3. You're left with 3 minus 1, or just the denominator 2. Here you still distribute. It's 2 times this, so 2 times radical 3 is 2 radical 3, and then 2 times a positive 1 is positive 2. So we would think that's done, but check this out. Because all 3 terms right here, the 2 terms on top and the 1 on the bottom, all have 2, we can reduce everything by 2, leaving us just the denominator, a radical 3 plus 1 over 1, or just radical 3 plus 1. So let's go ahead and try this one right here. So what will be the conjugate of this one? Yeah, it'll be the same thing, 2 radical 3, but it'd be plus radical 6. What you do to the top, to the bottom, you have to do to the top. So it'll be 2 radical 3 plus 6. So let's work on this one. We multiply that. Remember, outside numbers, you get 4 radical 9. This with this, you end up getting it's positive, so plus 2 radical 18. And then this one, with this one, you end up getting a negative 2 radical 18. And then radical 6 times radical 6 will be negative radical 36. To simplify that, you get 4 times 3 right here. These cancel each other out. Minus 6. You get 12 minus 6, or just 6 for the denominator. So 6 for the denominator. I'm going to do the top in blue down here because I'm running out of room right there. But so we still distribute. So you get 1 times 2 radical 3 would be 2 radical 3. 1 times radical 6. Ooh, I forgot square root. 1 times radical 6 is radical 6, of course. Negative radical 2 times 2 radical 3 is 2 radical 6. Remember, you multiply your radicals with radicals. And then radical 2 times radical 6 be negative radical 12. Can we reduce these? The only simplification that can happen are right here in the middle. So we get 2 radical 3. Oh, no, we can simplify the 12 too. We'll look at that. 12, of course, factors out to be radical 4 times radical 3. Which then gives us 2 radical 3. Check this out. So we add these two like terms up, and this is a positive 1 radical 6 minus 2 radical 6, being negative 1 radical 6, or just negative radical 6, but we'll leave it like that for now. Now, we have this negative 2 radical 3 right here. We got 2 of these. Look at that. They'll cancel each other out. So our final answer would be just radical 6, and negative radical 6 to be exact, because it's negative 1, so it's understood to be a 1. Now, these do not reduce. The reason why they don't is because this is a radical 6, and it's just a normal constant 6. That's our final answer, though. Hopefully this helps, y'all. Catch you on a different day. Bye.